Sensors can be used to detect interesting events that can be represented and manipulated in software. A basic embedded sensor performs a sense, detect, notify cycle. It senses a physical action or state. It detects a significant change in some physical state. It notifies the user or an application. A detector can identify significant changes in several different ways. A light going on or off, temperature going above or below a threshold, a sudden increase or decrease in the rate of change of temperature. Here's an example of a change of state of a door between open and closed. When the door moves from closed to open, it detects it open. When the door moves from open to closed, the sensor detects it closed. We can identify the event as a value time pair. We can use the events to compare the times at which two events occur or to build a timeline of a sequence of events. A Hall effect sensor can be used to detect proximity. Door sensors like those in cars are often built using Hall effect sensors. In a Hall effect sensor, a current flows across a metal patch from one edge to another. When a magnet is placed near the bar, its magnetic field causes the current to bend, resulting in a voltage across the sensor. Here's the circuit used to translate the Hall effect sensor output signal into a digital logic value. The Hall effect chip includes a pull-down transistor. An external pull-up completes the output circuit. To build a door sensor, we mount a sensor on the door frame and a permanent magnet on the door. When the door is open, the magnet doesn't affect the current trajectory and the current flows in a straight line across the sensor. When the door is closed, the magnet bends the current to a different location on the sensor, and that causes an event. The sensor's bus interface provides an addressable interface for the Hall effect sensor. The interface checks the address on the bus and compares it to the assigned address of the device. If they match, the interface responds. The interface must also check whether the requested operation is a read or write. A device can also use the interrupt system, which is a specialized subunit. Input devices use interrupts to signal an incoming input. Output devices use interrupts to signal that the requested output operation has been completed. In the CPU, a software function called a driver performs the read and write operations on the I/O device. The driver handles both the device registers and interrupts. Memory locations are assigned to I/O device registers. For example, a simple driver can be used to interact with an LED on the processor board. Thanks for watching.